I'm going to do practice problems, so this is the fourth video. And depending upon how long these take, I may break it up into two different videos. It just sort of depends. Um, but anyway, before we begin, we're going to use some things we developed earlier in the semester. So we looked at a graph of y equal f of x, and we saw what effect it had when you looked at f of minus x and y equal minus f of x. So what I want to do is review that. So we're going to use probably what's called a periodic function, so a sine or cosine or tangent. So I'm going to draw, that's my f of x right there. And I'm using the sine function. So I'm just going to put in a couple of values just so we can sorry, that's going to be plus 3 pi over 2 and 1. Okay, here, I can do the better job of that. That point is 3 pi over 2 and minus 1. That's what that point is right there. Okay, so we're going to see what happens when we do each of these things. And if you make this a minus x, that's going to reflect across the y-axis. So we're going to take this graph and shift it over here. So it's going to look like this. Everything else will be the same. And this point will be minus pi over 2, 1. And this point, which was 3 pi over 2 minus 1, will now become minus 3 pi over 2 minus 1. Okay. Now when we do minus x, we reflect across the x-axis. So let's see what effect that's going to have to this one. Well, this part is now going to be, remember we're taking this one, that's what the reflection is of this one. This is now going to be below, and this part's going to be above. Okay, and so this point, which was pi over 2, 1, is now pi over 2 minus 1. And that this point that was 3 pi over 2 minus 1 is now 3 pi over 2, 1. Okay, so this is going to be something we'll need a couple of times when we graph. So just remember, if that's a regular graph, minus x inside the parentheses flips it, reflects it across the y-axis. And if it's minus f of x, it just reflects it across the x-axis. Okay, so the other thing I wanted to do was look at the graph of f of x equals cosine of x. And it's going to look a lot like the sine graph. And I'm going to end up graphing it down here so we have it for a reference. But I want to go to Desmos. I think it's the easiest way to see it. So here we go to Desmos. Okay, and then here's the graph. Let's get this out of the way. Okay, and notice that it's pretty much like the sine, except it's like somebody pulled it back a little bit. Remember, the sine looks like this. Let's compare them. Notice the sine is the one in red, and so kind of what I imagine is that the sine is the one in blue, I'm sorry. And so what happens, what's this one? If you pull this one just forward a little bit, it'll match. So if you yank the sine graph forward, boom, so it overlays it. And the way to match it forward would be to translate it pi over 2 to the right. And if you remember, that's going to be to do that. And now the graphs overlay perfectly. Okay, that's a little bit of bonus. We don't need to know that. What's important here is that that's the graph of the cosine graph. Here, let's turn that off. And notice that it's, notice the point here, 0, 1. Here it's pi over 2. So basically, if we start here at 0, and we go till we come back to this point, we go down to minus 1 up to here. That goes from 2 pi 1, 0 pi 1 to 2 pi 1. So here I'm going to add a little comment. So the period, the way we find it is, notice that we start at 0, 1, 0 pi, sorry, 0, 1, right here, sorry, I said pi over 2, but 0, 1, and then, oops, and then we come back to that at 2 pi 1. So we go from 0, 1 to 2 pi 1. That's one cycle. And that's so, and then it repeats. So the period again is going to be 2 pi. Okay, and really the only difference is that it starts at a different place. It starts at 0, 1 rather than what the sine starts at 0, 0. The sine starts at 0, 0. The cosine at 0 pi over 1. So I'm going to draw a picture of the sine in paper. So I'm going to stop the share, and then we'll go back. Okay. So what we saw is that I'm going to do the sine and dotted line. Hopefully you can see that. And then the cosine is going to start here and end up over here. So this is going to be 0, 1. And it's going to do one complete cycle at 2 pi. So we're going to go here, down to here, over here at -1, cross the axis again, and come back up. So that's going to be one cycle. But remember, the graph is going to go from here. It's going to continue like that. So I think of this piece right here as one cycle. So it's almost exactly like the sine. The period is 2 pi, and the amplitude is 1. The only difference is that it's shifted. It's the sine graph shifted. Okay, so we're going to leave that alone for a while now and just start doing the practice problems. Okay, hopefully that will help. A little bit of review. Okay, so the first practice problem is we're going to look at f of x equal 8 sine of 5x. And it wants to find the period and the amplitude and then to sketch it. Okay. So you remember the period is going to be, if the graph looks like a sine bx, sorry, I should do this, it's a little bit messy there, then the period is going to be 2 pi over b, and the amplitude, absolute b in case b is negative, and the amplitude is going to be absolute a. Okay, so if we look here, we see that the amplitude is going to be, that's my a, that's my b. So the period is going to be 2 pi over 5. Amplitude, 8. So I'm going to graph this. I'm going to graph one cycle. And I'm going to transform. The way I'm going to do it is I'm going to start with the graph of the sine. There's one period. This is the point pi over 2, 1, 3 pi over 2 minus 1, and this is the point 2 pi 0 and pi 0. Okay, so I'm going to just transform this using these two things. So the first thing, so that's the sine. That's the parent function. So first we're going to look at y equals sine of 5x. So our period is now 2 pi over 5. So what's going to happen here is instead of going to 2 pi 0, we're going to go like this, but it's going to take, takes 2 pi, this takes 2 pi over 5 to go from here to here. So this point is going to be 2 pi over 5, 0. This is going to be half of that, so pi over 5, 0. This point is going to be half the distance here to here, so divide pi over 5 by 2, pi over 10. This point is pi over 10, 1. And this point here is going to be pi over 10, pi over 5, which is 2 pi over 10, 3 pi over 10, minus 1. So that's the graph of y equals sine x, 5x. And the next thing we do is we're going to stretch it. Remember that the amplitude is a, so keep that in mind. So I'm just going to pull this up. Oops. So now we can do this one over here is going to be y equals 8 times sine of 5x. We know what this graph looks like. We're going to end at 2 pi over 5, except we're going to go up to 8 rather than 1. So we're going to go higher, come back down, lower, and come back down. So this point was pi over 10, 1. That's going to be pi over 10, 8. This point down over here was 3 pi 10 minus 1. That's going to be 3 pi 10 minus 8. So that's what that graph looks like. And let's just check it with Desmos. Okay, let's take this one off. We'll transform this graph. We'll make it 5x. And let's just do here. Let's just do one cycle. So we're going to go from 0 to 2 pi over 5. And we're going to go from minus 1 to 1. Okay, and then I'm going to just go down a little bit. Okay, so here's one cycle right there. Notice 2 pi over 5, 3 pi over 10 minus 1, pi over 5, 0. It's exactly what I got before. And now I'm going to multiply this by 8, and then I have to shrink a little bit to get it. Okay, and again, I'm going to look at the x-axis just to get a better picture. I'm going to put 1 period on there, and I'm going to go from minus 9, oops, 96, to positive 9. So we get one cycle. Okay, let's take this off. So there's one cycle. Here, let's just go down a little bit so you can see it better. Here's the peak, pi over 10, 8, like we said. Pi 5, 0, 3 pi over 10 minus 8, and then that's going to be 5 pi over 2. I'm sorry, we're going to go here. 2 pi over 5, 0. Okay, that's one cycle. Okay, good. Okay, so we'll do the next one. Let's stop the share, and we'll go to the next problem. Okay, the next problem is going to be, sorry, I should have moved these out of the way. Problem number 2 is going to be g of x equals minus 6 cos 2x. Oops, you can't see that. Now you can see it. Again, we want to find the period and the amplitude. That's A, that's B. 2 pi over B is going to be 2 pi over 2, so just pi. That's going to be the period. The amplitude is going to be A, which is absolute minus 6, which is 6. Okay, so let's see what the graph looks like. This is the cosine. Remember, one cycle of the cosine looks like this. It starts at 0, 1, crosses at pi over 2, pi minus 1, crosses again at 3 pi over 2, and then one cycle ends at 2 pi 1. So we're going to take that graph. This is 2 pi for 1 period. We're going to make it 1 period. Take the same graph and make it 1 period. So we're going to go from here to here. Again, this is going to only take pi for the cycle. So we're going to have 0, 1. Over here, we're going to have pi 1. This was pi over 2. The cycle's half as long. So we're going to cross at pi over 4, 0. This is going to be pi over 2 minus 1. It was pi over minus 1. We're cutting it in half. This is going to be 3/4 pi, 0, and pi over 1. Okay. So now we have to, we're going to do the minus 6. That's going to flip everything across the x-axis. So it's going to go like this. And then it's going to be minus 6i. So first we'll do the minus to flip it. So it's going to look like this. Just the opposite. This was 0, 1, so it's going to be 0 minus 1. This was pi 1, so it's going to be pi minus 1. This was pi over 2 minus 1. That's going to be pi over 2 plus 1. That's just the minus. So this was y equals minus cosine 2x. And now we're going to make it minus 6 over here. So we're just going to take this graph and stretch it so it looks like this. It's going to go down to 6, go up to 6, back down to minus 6. So this point here is going to be pi over 2, 6. This point down here, this is supposed to be the x-axis. And the y-axis, this point here was 0 minus 1. It's going to be 0 minus 6. This point was pi minus 1. It's going to be pi minus 6. Sorry, that's kind of in the shadows. I'll try to avoid that. Here, let me move it up just a little bit so you can see it better. Okay, so that's what the graph looks like. It's a horrible picture. Let's go to see what it looks like at Desmos. And so we're going to go here. We're going to share. It's going to be based on the sine. So we're going to have a 2. Let's turn the graph on. So again, we want to adjust the setting so it looks right. So we have it minus 1, 1. And we're going to go from 0 to 2 pi. I'm going to just back down a little bit. So there's one cycle, 0, 1, pi over 2 minus 1, crosses 3/4 pi, pi over 2. Then we do the minus, and that's going to flip it around, but we really want a minus 6. So let's go out a little bit, and let's change the settings. We want to go from minus 6 to 6, and I still want to go from one cycle, so I want to go from 0, the period was pi, so let's do that. And then I'll come in just a little bit, oops, I'll go out just a little bit. And that's the graph. Notice that the low point is 0 minus 6, crosses the axis pi over 4, 0, just as we said. Goes up to pi over 2, 6, crosses 3 pi over 4, back down to pi over 2, 0. Okay, so here we don't need that. Okay. Again, so just want to get a picture. I'm just going to just back down just a little bit so you can see the graph just repeats itself. Okay, we'll stop the share and do the next problem. It's going to be number 3. It's going to be f of x equals 3 sine minus 2x. Oops, sorry, you can't see that. F of x equals 3 minus 2x. The period, there's b, there's a. The period is 2 pi over absolute minus 2. So again, a period of pi. And the amplitude is going to be absolute a, which is 3. So this is going to look like the sine. It's going to have a period of pi. It's going to be, that's going to reflect it across the y-axis. So again, I'm going to go over the whole thing. I'm going to start with y equals sine of x as a parent function, and we'll just transform it. Here's the sine graph. 2 pi 0, pi over 2, 1, pi 0, 3 pi over 2 minus 1, and 0, 0 right there. Okay, so we're going to do y equals sine 2x. So the period now is just going to be 1. We're going to go to pi over 0, so we're going to go up, down, and over. So again, everything gets cut in half. That's pi over 4, 1. That's 3 pi over 4 minus 1. And that's going to be pi over 2. That's a half a cycle. Pi over 2, 0. That's pi 0. Okay. Now we're going to do the minus 2x. That's going to reflect it across the x-axis. So we're going to take this graph, and now it's going to look like this. This will be minus pi over 2, 0. This will be minus pi over 4, 1. This will be minus pi 0. And this will be 3/4 pi minus 1. Sorry, minus 3/4 pi minus 1. And so now we're going to do y equals 3 sine minus 2x. I'm going to take this but go up to 3. So I go higher, lower, and back. This point is going to be minus pi over 4, 3. This point is going to be minus 3/4 pi minus 3, and so forth. Okay, so that's what it's going to look like. Let's check against Desmos. So we'll go back. Okay, so we're going to use the sine function. I'm just going to go to minus 2x. Going to make the graph here. I want to make the graph legible. So there's minus 2x, there's one cycle, minus pi over 4, 1, as we said, minus pi over 2, 0, minus 3/4 pi minus 1, and that. So now we're going to multiply by 3, and it's just going to stretch things. Let's just come down a little bit. You see it stretches it. I'm not going to go through and look at it in more detail. So again, minus pi over 4, 3, as we said, minus 3/4 pi minus 3, minus pi 0. Okay. Again, so hopefully you're getting the point. Okay, let's go back, stop the share, just so you can see what we came up with. Yeah, it looks much better on Desmos, but that's the graph. Okay. So now we're going to do the tangent. Now remember, if we look at the y equals tangent x, the tangent period is equal to pi, the normal one. So when we have y equal tangent bx, the period is going to be pi over absolute b. So here we have y equals tangent x, b is equal to 3. So the period for y equals tangent 3x is going to be, the period is going to be pi over 3. So the tangent graph normally looks like this. One cycle goes from minus pi over 2 to pi over 2. That's what the tangent graph normally looks like. So y equals 3x is going to go, this distance was pi, one cycle. This distance is going to be now pi over 3. So it's going to go to instead of pi over 2, the period's cut in 1/3, so this is going to be x over pi over 6. This asymptote is going to be x equals minus pi over 6. So it's going to go like this. It's just going to be a shorter period. So again, let's look at what happens with the tangent function. Let me turn that off. Let me add k of x equals tan x. And then I also want to add this. I'm going to add the asymptotes. We talked about this in the graph. For that, I'm going to keep the asymptotes dotted in green, and I'm going to make the function red. Okay, so that's y equals tangent of x. Now notice how when we do 3x, it's gonna make things shorter. So I said that this had to be, we have to divide pi over 2 by 3. That's going to be pi over 6. Same thing here, bottom becomes 6. And let's just zoom in a little bit. And you see it looks like that's going to work pretty well. I want to adjust the settings just a little bit to show you. So it's going to be pi over 3 minus pi over 3. Just want to give us a little bit more room. And the y-axis, let's make it big. 10's not very big. Okay. So let's, okay. So I tried to zoom in on 1. Let's just zoom out just a little bit. You can see now. This is pi over 6, the new cycle is right between them, just as we thought. Okay. Okay, so the next graph is going to be tangent of minus 3x. So that's going to be the fifth one. I'm just going to do that here. And remember, when I put the minus sign here, it's going to reflect over the x-axis. So I want you to think about what that's going to look like. And then I'm going to hit the minus sign. So think about it, pause it if you need to. I'm going to hit the minus sign. Oops, wrong one. Hit it in the wrong place for all that drama. My mistake. I'm going to change the minus sign here. It just flipped it over. You see the part before, that's what it looks like for 3x. Minus 3x, the same period, except it just reflects it across the x-axis. I'll do that a couple of more times. That's what it looks like. Now we'll reflect it. Okay. This part's going to now be below the x-axis in this direction. This is going to be above the action, but twisted a little bit. So that's what we got. Okay. So we just did 4 and 5. So I'm going to stop the share and go back and do a couple more. Okay. So number 6 is going to be g of x equals 3 plus 5 sine x. This is just going to move the graph up 3. It's not going to change the amplitude. So let's look at what the graph looks like. I'm going to go to Desmos just because it's a little bit simpler. Okay, let's turn off these. I think we're done with the tangent, so I'll keep those on. So we're going to look at the graph of, I said it was 3 plus 5 sine x. Okay, let's turn it on. Let's see what it looks like. We want to zoom out just a little bit. Okay, and then what I want to do too is I'm going to do something here. I'm going to graph the line. Here, let me add. Okay. Okay. So what I'm doing is, hopefully this makes sense, is that I'm going to first look at the graph 3 equals sine x. That's going to raise the graph up. The whole thing gets shifted up 3. So the line of symmetry also gets shifted up 3. Okay, so in other words, the graph is going to be equally high above y equal 3, equally below. Let's zoom in just a little bit, and you see that, okay, I go from 4 to 2, but I'm only 3 above the middle point. So the amplitude is still going to be 1 for 3 sine x. Now when I multiply this times 5, notice the high point is going to be 8, the low point is minus 2. It's still 5 above that line y equal 3, 5 below y equal 3. So the reason I picked y equal 3 was to match this. And basically, the whole graph just gets shifted up, but so do all the symmetries. So basically, I'm going to go back and analyze it now, and then we'll come back. So I'm going to stop the share. Okay. So here we go. This just moves up 3. It doesn't change anything else. It doesn't change the amplitude, and it doesn't change the period. Remember, the amplitude is not the high point. It could be, but it doesn't have to be. It's the height above the middle. Okay, so that doesn't change the amplitude. So again, the amplitude is still going to be A. The number in front, which is a 1, is going to be used to determine the period. So the period is still 2 pi because it's sine of x. The amplitude is 5, and it was shifted up 3 by that. And again, that does not change the amplitude or the period. It just moves everything up. So let's go back and look at the picture one more time just to make sure that's clear. Okay, amplitude is the height above the middle point. So the middle point is here at y equal 3 because we shifted up 3. Amplitude is still 5. 8, 10. Okay. Another way to think about the amplitude is you take the high point and the low point and take their average. So 8 minus 2, that's 10. Divide by 2, that's 5. Okay. So an alternate way for amplitude is the highest minus the lowest divided by 2. The highest here was 8, as we saw. The lowest is minus 2, as we saw in the graph. Or you can see on the graph, as I pointed, we divide by 2. You get 10 over 2 is 5. So let me go through that again so you can see it. Stop the share. Amplitude. Highest minus the lowest. Our highest was 8. Minus 2, so it's plus. That's 10 over 2 by 2 is 5. You can either think of the amplitude that way or just think the amplitude is this, and that does not change anything. That was the whole purpose of that, to show that we can move it around, but that doesn't really shift anything. Okay, we got 2 more of these and then 2 applications. I'll do the applications in a separate video. Okay, so now we go to number 7, and we have k of x equals 3 sine 2 pi x. Okay, that's my b. Is 2 pi. A is 3. Amplitude equals 3. Period equals b over 2 pi. Sorry, I had that wrong. 2 pi over b. So b is 2 pi, so 2 pi over 2 pi equals 1. This is called normalizing the period to 1. So anytime you see a 2 pi here, the period's going to be 1, and sometimes people write it that way. Okay, so again, you think we're going to have the sine function. Its period's going to be 1, and its high point is going to be 3. So we have the sine shape, but just the period is 1. Okay. And that point up here would be 3 1/4. The low point would be minus 3 plus 3/4. Again, let's look at the graph, see what it looks like. Should look better version of that. So again, we're going to use the sine. We had a 3 here, and we had a 2 pi x here. We don't need this anymore. We can even come in a little bit and see what it looks like. You can see the period is 1. The high point is going to be at 1/4. Oh, there should be a 3. Yep. The high point is going to be at 1/4 3. It's going to cross the axis at half the period. So 1/2 0. The low point is going to be 3/4 minus 3. And then we're going to complete the period at 1.